Hello again everybody at Flyby Virtue. Welcome back to the second part of this training video, and we are, if you remember, looking at the various switches and instruments in the flight deck before we have a look at the various phases of flight and standard operating procedures. The next display we're going to look at is the Multifunction Display, which is to the right of the primary flight display. There is a large variety of information that we can present on the multifunction display. At the moment you can see we have a systems page selected, and it's actually showing us the status of the doors. At the moment you can see the left front entry door is currently open. The selection of system pages can be done using the control panel here on the pedestal. The switches allow us to select the presentations that we would like to display on each pilot's multifunction display system, the left one being for the captain, of course, and the right one being for the first officer. You can see at the moment that they're both currently in system mode, which means that both multifunction display systems will present systems pages. So if we look up now, you can see the left one is currently showing the doors page, and the first officer's multifunction display unit showing the electrical page. By the way, this is standard procedure when on the ground during the cockpit preparation and pre-flight phase to have the multifunction display units both selected to system, and to have one selected on doors so that the status of the doors can be monitored, and the other one set to electrical. In addition to the multifunctions, the MFDs also have static, unchanging parts to them. At the bottom, on the captain's side, we have a constant monitor of the flight controls, and on the first officer's side we have a constant monitor of the hydraulic systems and also the position of the flaps. In addition to showing systems pages, we can also use the multifunction displays as primary flight displays, in which case the PFD reverts to the right hand side. This is an abnormal configuration and would only be used in the event of a screen failure. It can also be used as an engine display if the center engine display fails, and, as we'll have it in flight, can also be used as a nav or navigation display. We'll have a look at that in greater detail later on. In the meantime, let's have a look at some of the systems pages in turn. The electrical system on the Q400 is fairly straightforward and also fairly standard. We have obviously both a DC and an AC electrical system. The AC system is generally only energised when the engines are online, though an AC external power source can be connected to the aircraft, though this is fairly rare. The external power indication is shown obviously by the green light at the top of the screen, DC external power on. And it's important to make sure that this light is illuminated if the APU isn't online. Otherwise, of course, electrical power will be draining the batteries. For safe operation, it has to be made sure that battery temperatures are above -20 degrees Celsius. We have 3 batteries on board, and the loads for each battery, main, auxiliary and standby, are shown, as well as the temperatures for each battery. Below that we have the indications for the voltages for the essential, main and secondary DC bus bars. In the middle we have the load of the APU generator, which is obviously 0 because the APU isn't online at the moment. We have the loads for the DC engine generators, which also are not online. And we also have the loads for the TRUs, or transformer rectifier units, which transform 115 volt AC electrical power generated by the engine generators into 28 volt DC power, which is then fed to the DC bus bars as a supplement to DC electrical power generation. You can also see the voltage and loads for the AC generators, which are not currently online. If we were to take a look at the electrical panel now on the overhead, the DC controls first of all. The top three switches on the left hand side are for the batteries, standby, auxiliary and main. And we also have the battery master switch, which connects all of the batteries to the DC bus bars. Here we have the master switch for the DC engine generators, which are always left on. The master switch for the DC external power connection, which is on at the current time, as we're on the ground with the APU offline. The main DC bus bars are connected by what we call a bus tie, which ensures that if one of the DC bus bars becomes de-energized, perhaps due to a generator failure, the two bus bars become interconnected, and the main bus tie switch is the master switch for that option. The electrical system is monitored by the Electrical Power Control Unit, or EPCU, and following a fault, perhaps with one of the bus bars, then the bus fault reset can be momentarily depressed, and that will ensure subsequent monitoring of the system following a fault. Over on the other side of the overhead panel, the AC controls, this control panel is obviously much more straightforward. We have the master switch for the external power, AC external power supply, which at the moment is off. We don't have AC power connected. And we also have the master switches for the AC engine generators, which are always left on. Let's take a look next at the fuel system. The fuel system on the Q400, as you'd expect, is very, very simple. There are two collector tanks, one in each wing, and the total fuel capacity is 5,318 kilograms. Tank 1 feeds engine 1 and tank 2 feeds engine 2. There is no cross-feed capability as there is in bigger airplanes like a 737 or an A320. There is, however, the possibility to transfer fuel from one tank to another, and this can be done using the fuel transfer switch on the center panel. The minimum fuel imbalance that is allowed between each tank is 272 kilos. So if an imbalance between the two fuel tanks shown on the fuel gauges here on the engine display become greater than 272 kilograms, then the fuel transfer option will have to be used to transfer fuel into the depleted tank. An imbalance may occur if the auxiliary power unit has been used for an extended period of time. Tank 1, or the left tank here, supplies not only the left engine but also the auxiliary power unit when it's running. So you may find that if you've been using the APU on the ground during the turnaround, on departure there may be an imbalance between the left and right tanks because the APU has been using fuel from the left collector tank. Fuel is fed to the engines usually via an ejector pump to an engine-driven pump, or via an auxiliary AC electrical pump. The master switch can be found here on the center panel. The auxiliary pumps generally aren't used in flight, but are used prior to departure and also for the approach as a backup for the fuel system. The fuel display itself shows the quantity in each tank, shown in the form of a round gauge. We have the status of the fuel valves themselves, currently closed as the engines are offline, and the status of the transfer between tank 1 and tank 2, and again that's switched off as you'd expect. The total fuel capacity is shown as a digital readout as well as the analog gauges, and the fuel readout for each tank is shown again on the engine display.